We've been looking at polynomials. Today we're going to look at how you can solve a polynomial equation. So we want you to be able, in order to do that, to first factor it and then be able to solve it once you've factored it. All right, so just to review factoring a little bit, let's look at some of these ones here. Number one, we want to factor this one out. Now notice it has a 2 here. So first thing you'd want to check, could we factor out a 2? Would all these be divisible by 2? Well, the first one works out nice, but the next two, if we try dividing by 2, give us decimals. We don't want to move to decimals in order to factor this one. So looks like we're going to have to factor this one out by saying this is going to be 2x times another x in order to multiply these and get our 2x squared that we see here. Okay, so we know it's got to be 2x and x. Now the rest of this to factor, we want to know, we can use our clue that we know these other two numbers need to multiply in order to equal negative 15. However, because of this 2, the two numbers will not add to equal negative 7. So we got to kind of use our little guess check method here to figure out what's going to work. So our combinations that could multiply to negative 15 would be like negative 15 and positive 1, positive 15, negative 1, 3 and negative 5, or negative 3 and positive 5. So what combination, when we put them in there, will end up adding up to equal the negative 7? Well, let's just try a combination out and see if it works. Let's try 5 and 3. And we know this is going to have to be negative, 1 negative, 1 positive. So let's try multiplying this out. For sure, these two are, the last two numbers are going to multiply to negative 15. We don't have to worry about those. And we know the first two multiply to 2x squared. It's these two and these two. Will that combination multiply out and add up to equal negative 7? Well, if we multiply the two outside ones, we get 6x. If we multiply the inside ones, we get negative 5x. Will those two now add up to equal negative 7? No, they equal positive 1. That combination's not going to work. Okay, so let's try switching them around. Let's put here negative 3 and positive 5 and see if that works. Okay, so now if we multiply this out, these would be negative 3x, and if we multiply these, that would be 10x. So does that combination work? Well, it's closer. If we add these up now, we get 7, but it's a positive 7. We want a negative 7. So I think we're safe with where the numbers are. What we need to do now to get this one to come out would be to switch the signs around. So if we switch this to a positive 3 and a negative 5, now we got this factored out. These two multiply to positive 3x. These two multiply to negative 10x. Those do now add up to negative 7. So that would be the correct factoring for this one. So that would be our answer. Okay, 2x plus 3 times x minus 5. Let's try another one. This one is not a quadratic, number 2. This is not a quadratic like the last one. So then we want to look for what's the greatest common factor. Here looks like 25 and 15. We can factor out a 5. Now we want to look at what's the greatest common factor of our variables. Looks like the first one has 3, the second one has 2. We can at least take 2 a's away from both of those. We got 5 b's and 6 b's. We can factor out at least 5 then. So now we want to write what's left over. It's kind of like the opposite of distributing. So 25 divided by 5 would mean we're going to have a 5 here. We need one more a, and actually all our b's are already gone, so we don't need any more b's there. The next one, 15 divided by 5 would be 3. A's are all gone, but we do need one additional b there, so that would be the factorization of that one. The last one here, and we're going to be talking about a little bit more with these today, but we have looked at them before. What this one is, x squared minus 81. Now notice there is no greatest common factor. We can't factor out an x because the second one doesn't have an x, and there's no numbers we can factor out because the first one doesn't have a number. But this is one of those quadratic ones like the first one. Anytime your biggest degree is 2, that's a quadratic. Okay, what we want to be thinking on this one is it's x squared, and there's this minus 81. It's that we don't have that middle x term like we had in that first one. So it's almost like a plus 0x. So we want to think, what's going to multiply to negative 81? What two numbers are going to multiply to negative 81, and the same two numbers add to equal 0? Well, in this case, that would turn out to be positive 9 and negative 9. Positive 9 times negative 9 is negative 81, and if we add 9 and negative 9, u equals 0. So that is how that one factors. That's called a difference of two squares, and we're going to get into that today. So when you're factoring, always look first, like we just looked at, always take a look first to see if you can factor out the GCF, or the greatest common factor. So always take out the greatest common factor first, the GCF. Okay, once you've done that, then look to do some of these other types of factoring. So the other types of factoring that we're going to be doing here are called the difference of two squares, okay, the sum of two squares, and the difference of two cubes. Okay, so on this one, this is these first ones. These are, if you look, the biggest power is power 3 here. So that means we want to be looking to do one of these cubed ones. So on a cubed one, okay, we're going to be using these two cube patterns. So you, when you're doing either a sum of two cubes or a difference of two cubes, it's this pattern that you see down here. Okay, we want to be doing this pattern. And so what we got to do is figure out what is actually being cubed here. What's the number being cubed? So on this, on number 4, what's being cubed right here? It's x. X is being cubed. Okay. On the second one, we also want to figure out what's being cubed. There's some number that when you times itself 3 times, it's going to equal 125. Now, some of you might be able to guess what that is. It is going to end up being 5. But how you can figure it out if you're not sure would be one of two ways. One thing you could do is to, on your calculator, just try guessing some numbers. You could do 5 to the third power and guess, yep, it's 125. If you want to take the guessing out of it, though, you can do the opposite. The opposite of cubing something would be to take the cubed root. Okay, and remember, to get to the cubed root, you can hit your math button, and it's on there. Here's number 4 is the cubed root. And then if you type in 125, it'll tell you the cubed root of that is 5. So 5 is the number being taken to the third power. Now, that's not how we factor it, though. We're just trying to figure out what are the two things being cubed. Now we're going to use this factor pattern to help us out here. So down here, what we want to do is put it into this pattern. So the first thing is a plus b. So whatever your a and b are, you're just going to add it together. Here are a and b. A is going to be 5, or x, I mean, b is going to be 5. So the first part of this is just going to be x plus 5. That's the first factor. The second factor is going to be the second one. So if you look here, the next part of this has a squared. So whatever the first thing is, we want to square that. So we're going to be squaring that. Minus, there's always a minus next. Now we want to times together what a and b are for the next one. Okay, so if we times together the two things, it's going to be x and 5. Plus, okay, because there's always a plus in here. Now the last thing is the second thing squared. Remember, we had the first thing squared, now the second thing squared. So now we want to take second thing 5b and square it. So if we simplify that second one, we got the answer now. So factored out, this is going to be x plus 5. X squared is just x squared. X times 5 is 5x. And then 5 squared is 25. And that is how you factor that one out. If we were to go now through and multiply all that out, we would end up with x cubed plus 25. Okay, just to show you that it works, let's multiply that out. So if we were to multiply these two, you get x to the third. If you multiply these, you get minus 5x squared. If you multiply these, you would get plus 25x. Now you'd have to distribute the 5 to each. So if you multiply that, that's plus 5x squared. If you multiply these, you get minus 25x. If you multiply the last ones, you get plus 125. Okay, notice what happens here. Negative 5x squared plus 5x squared, those cancel out because they equal 0. 25x minus 25x, that equals 0. The two things left are the two things we started with. Okay, so once you have it factored, you should be able to check if you wanted to by multiplying that back out. All right, let's try another one of those. So the next one here, we want to factor what is this. Okay, and notice we want to look, is there a greatest common factor? 8 doesn't go into 27, so we can't do any greatest common factor. But this is another one of those cubed ones. We see a power 3 here. So it's another cubed one. So we want to figure out what's being cubed on each of these. Okay, so the first one, there's definitely an x being cubed. What number times itself 3 times would equal 8? Well, if you're not sure, do the cubed root thing again. Let's do math. Let's do, what's the cubed root of 8? And the cubed root of 8 is 2. So 2 times 2 times 2 equals 8. So 2x is being cubed there. Okay, the next thing we got is negative 27. What number times itself 3 times would be cubed root of negative 27 here? Well, let's see. We do the cubed root again of negative 27. That's going to be negative 3. So negative 3 is being cubed here. So now put it into that same factor pattern and let's see what we get. So the first one is always just these two things, 2x plus negative 3. Okay, the next one has 3 things in it, and basically if you can kind of remember, there's going to be 2 of everything. There's going to be 2 of the first thing, then 1 of each, so that's 2 things, and then 2 of the last thing. So we got to square the first thing, square 2x, minus, now we got to multiply these 2 things because we need 2 of everything, and then it's going to be plus 2 of the last thing, 2 of negative 3 squared. All right, so let's simplify that. So we got 2x plus negative 3, we can write that as 2x minus 3. We got to square 2x. So if we're squaring 2x, remember squaring means you're multiplying 2 of them together. What's 2x times 2x? That's going to be 4x squared. Okay, now we got to multiply here. We're multiplying 2x times negative 3. That's going to be negative 6x. Now we got minus a negative here. That's going to end up being plus 6x. Okay, and then we got negative 3 squared to finish. What's negative 3 times negative 3? That should be positive 9. That's how we would factor that one. If you were to go through again and multiply all that together, you should get the same thing that we started with. Okay. Then these next ones, these are not power 3. You can see we're back to different powers here. This is a power of 2. Okay, so this one's not one of those cubed ones. We should check again, is there a greatest common factor? Nope. But this is one of those difference of squares. What is the perfect square that number times itself that equals 49? 7. So this would be 7 and 7. One's positive, one's negative. Okay, the next one, number 7. This one is not a power 3 one either, but it's not power 2, it's power 4. So what are we going to do on this one? We haven't had a power 4 yet. But remember, we want to be able to factor this one using some perfect squares here. So there is actually some perfect squares. If we do something similar to the last one, okay, and we multiply this out, we know 81, that's 9 and 9. And one has to be positive, one has to be negative. If we were to do it like the last problem, it'd be like this. Well, the problem though is x times x is only x squared, and we got x to the fourth. So what should we change on this in order to make it equal x to the fourth? Well, let's just increase the power. If we increase these to both squared, now x squared times x squared would be x to the fourth. And now that is how you factor that one. But we want to remember, try to factor it completely. So do either of these factor anymore? The second one does. This is one of those problems like we just did over here. That's one of those difference of perfect squares. So this one we can break down farther. 9 is a perfect square. So what is the two things that this would factor to? It would be x and x. And then the perfect square that times to equal 9 would be 3. So plus 3 and minus 3. Now, does this first one break down like that too? No, the first one doesn't, because if we would try doing it as x plus 3 times x minus 3 like the other one, that doesn't work, because plus 3 and minus 3 would equal negative 9. This is a positive 9. Now, you might think, well, is it plus 3 and plus 3? No, watch what happens if we multiply this out using FOIL. You'd get x squared plus 3x plus another 3x plus 9. So that 9 and x squared are there, but you got these two 3x's. Those two 3x's are not up there. So this one does not factor anymore. There is no other factors of this. So we would leave our answer as right here. This would be the completely factored out version of that. Let's try a few more here. So let's look at number 8. Number 8, we want to factor this one out. So what do we get on this one? You got x to the fourth minus 23x squared minus 50. Now, there's no greatest common factor here, and this one is one of those x to the fourth ones, but we can do it similar to how we just did the last one. Okay, we can still use our little tricks before from quadratics. You got what's going to multiply to negative 50 and also add to equal negative 23. I think a combination that would work here would be minus 25 and plus 2. Now, this would be how we would do it before, but remember, x and x only equal x squared. We got x to the fourth. So in order to make this one work, well, let's just increase the power on those. If we change both of these to squared and squared, now it's going to work out better for us. So x squared times x squared would now be x to the fourth. Now we want to check, do either of these factor anymore? Yeah, this one does. This is one of those difference of squares, so that would factor to x plus 5, x minus 5. Since the other one doesn't factor, we'll just leave it how it is. That's the completely factored version of number 8. Why don't you pause the video, try number 9 out, see if you can factor that one. All right, let's see how you did. This one, it's going to be x squared and x squared because we got x to the fourth here. Well, it's going to multiply to that and add to that. You might have to just try some numbers out, but if you figure it out right, it should end up being plus 9 and minus 7. Now we want to check, do either of these factor more? 7, not a perfect square, so that's not going to factor. 9 is a perfect square, however, if it's plus, no, it's not going to factor anymore. That's the answer. That one doesn't break down any farther. That would be the factored out version of that one. Okay, so on the back now, we're going to look at actually solving these now. All we did so far was factor. To solve, what we want to do is when it's equal to 0 is factor it out, get it equal to 0, and then what we want to do is solve it out and see what does our answers come out to be. What does x actually equal when we're all done? Okay, so we can still use our little clues of whatever it is should multiply to that number and add to that number. The only difference is if you have an x to the fourth, these are going to be x squared and x squared. All right, let's try some out. Let's go to a kind of a one you're more comfortable with. We've done a lot like number 10. Last trimester, you did a lot of these. So on this one, what does this factor to? This would factor to x minus 7 times x plus 2, because negative 7 times 2 is negative 14. These add to equal negative 5. Now we want to set them both equal to 0 to find our answer. Okay, so if we add 7 here, one answer is going to be 7. If we minus 2, those cancel, and we get another answer of negative 2. These two numbers, if we were to go back and plug those numbers in for x, like if we plug in 7, this is going to make that equal 0. We get 7 squared, which is 49, minus, if we multiply that, that's 35, minus 14, and if you put that in your calculator, it does in fact equal 0. Same thing would happen if you plug negative 2 in. So we want to take that same idea now and apply it to some of these other problems. So let's look at one like number 11. Okay, what's the answer going to be here? Well, we want to go through and figure out how we're going to factor this one. There's no greatest common factor. It's an x to the 4th. Well, that's going to be similar to those ones we were doing on the other side. It factors like a quadratic. The difference is it's going to be squared and squared. So now we want to figure out what multiplies here, and the same two numbers add to equal negative 13. I think on this one we can try some different things. 36 might be like 6 and 6, but 6 and 6 won't equal 13. We could try 12 and 3. 12 and 3 won't give us 13. 9 and 4 is another thing. I think 9 and 4 can give us 13. Okay, now we got to figure out what are the signs going to be. Well, I see a positive here, so we could try two positive, plus and plus, but I see a negative there. So it can't be plus plus, they must both be negative on this one. Okay, so now we want to check, do either of these factor more? Okay, does this one factor more? I think it does. This one looks like a perfect square here, and it's a minus, so it does. So this would break down further to x plus 3 times x minus 3. 3 times 3 is 9. All right, does our second one factor further? We got a 4, which is a perfect square, and a minus. Yep, it does. So this one would factor to x plus 2 times x minus 2. It's another difference of squares. So now on this one, since we got 4 factors, we want to set all 4 equal to 0 and see what we get. If you set the first one equal to 0, one answer is going to be negative 3. If we set the second one equal to 0 and add 3, another answer is going to be positive 3. Similar with the last two, we get an answer of negative 2. And if we set the last one equal to 0, you get positive 2. Okay, and so those would be the 4 solutions to this one. What that means is if you were to graph this out, you would see that this graph crosses the x-axis 4 times at these 4 spots. Okay, just to show you that, let's graph out on our calculator this graph. So I'm going to put in our calculator that equation, x to the 4th minus 13x squared. Try that again here. X to the 4th minus 13x squared plus 36. Watch what happens when we graph this one out. Where does this graph cross the x-axis at? Make it a little bigger so you can see it here. Okay, you can see this graph crosses the x-axis at negative 3, at negative 2, at positive 2, and at positive 3. So those same numbers we had over here, that's all the zeros. That's the roots. That's the places where it crosses the x-axis. So you can find those roots by doing some factoring and solving. All right, let's try a couple more here. Okay, number 12. See if, why don't you pause the video, see if you can try this one out, see if you can factor and find the solutions for number 12 here. All right, let's see how you did. This one factors like one of those quadratic ones, except it's going to be x squared and x squared, because since we got x to the 4th. Now what's going to multiply to 225 and add to negative 34? These are kind of some bigger numbers. On one like this, I would probably try dividing using your calculator since we got kind of those bigger numbers here. So like 225, since it ends in a 5, I know something with 5 probably divides in that. So I don't know, I'm going to try what's that divided by 5. So 5 and 45, would that give us 34? No. I'm going to try dividing by 15. 15 and 15, will that give us 34? No. Let's try 25. That ends in a 5. 25 and 9, does that give us 34? Yep. So this one's going to end up being minus 25 and minus 9. All right, do these factor further? Yes, both of them do. This factors to x plus 5 and x minus 5. This one factors to x plus 3 and x minus 3. We're not done though. It's equal to 0. We want to keep solving all the way for our answers. So your answers you should get here is negative 5, positive 5, negative 3, and positive 3. This one has 4 different solutions, 4 different zeros on it. All right, one last one here. Let's try this one together. On number 12 or 13, let's factor this one. Okay, how's this one factor? Uh-oh, a little bit different now, power 3. This is one of those cubic ones again. So we want to figure out what's being cubed. Here, x is being cubed. Here, we got to figure out what number is being cubed. So let's, on our calculator, figure out what's the cubed root of 64. What number times itself 3 times would equal 64? 4 does. 4 times 4 times 4 is 64. It's 4 times 4 is 16, times another 4 would be 64. All right, so now we want to put it into that that sum pattern here that we had before. So what's this one going to be? Well, if we look at that pattern, that's this one here. What's that going to be? We got a plus b. So we want to have the two things here, x and plus 4. Okay, now the second one, you want 2 of everything. 2 of the first one, and then 1 of each, and then 2 of the last one. So if we have 2 of the first one, that's going to be x squared minus, it's always minus, then 1 of each, x and 4, plus, and then we want 2 of the last one, 2 of the 4. Okay, now let's just simplify it. So x squared is x squared, x times 4 is 4x, and then 4 squared is 16. That's the factored version of that one. Now, I shouldn't have circled that because we're not done. This is equal to 0. Okay, we want to solve this equal to 0. So we want to keep going here. What is this going to be once we solve it out now? So we want to put both of those things equal to 0. We want to put x plus 4 equal to 0, and we want to put this equal to 0 and solve it out. First one's easy, just minus 4 from both sides, and one of the answers is negative 4. Okay, other one, all right, we got x squared minus 4x plus 16. Well, this one looks like a quadratic. Let's see if we can factor it out. Does this one factor? Is there anything that multiplies to 16 and adds to negative 4? Well, 16 could be 4 and 4. That can't give us 4. It could be 8 and 2. That doesn't give us 4. That would give us either 10 or 6. Let's try 16 and 1. Does that give us 4? Nope. And that's all the possibilities. So this one doesn't look like it's going to factor. Some problems just don't factor. However, there is another way we can solve this from last try. We can use quadratic formula. Any quadratic can be solved with quadratic formula. So we want to figure out what's our a, b, and c here. A would be 1, b is negative 4, c would be 16. Let's put that in the quadratic formula and see what we get. Recall quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So if we put our numbers in for this one, we would come up with opposite of negative 4, which is going to turn out to be positive 4. Square root of negative 4 squared minus 4 times 1 times 16. All over, the whole thing is over 2 times a, which is 1. So what is this going to give us here? We already said that's positive 4. 2 times 1 on the bottom, that's easy, that's 2. We got this square root part. Let's put that in our calculator, see what we get. So we got negative 4 parentheses squared. Well, I didn't quite enter that right. Let's try it again. Negative 4 squared minus 4 times 1 times 16. We get negative 48. So we have over here square root negative 48. Uh-oh, problem. What's going to happen when we try doing that on the calculator? Not going to end up with a good result. Can you take square root of negatives? Nope. And so it doesn't look like this is going to give us any more real solutions. There's not going to be any real solutions that come from that part of it. Okay, so the only real solution on this one is negative 4. If we were to graph this problem out, you're only going to see across the x-axis one time at negative 4. Now, however, if this was like a ACT question, they might show the real answer with the imaginary ones. Remember, we can still come up with a number for this by making this into an imaginary number. So if we take that negative and make it into an I for the imaginary numbers, we could probably still figure out an imaginary solutions for these. So if we just take that negative, make it into 9, now we could simplify this maybe a little bit more. Square root of 48, I think, has a perfect square in there. 48 is the same as 4 times 12, so we could write it as square root of 4 times square root of 12. That equals 2. So we could write this as 4 plus or minus 2i square root of 12 over 2. All right, well, since we got 2 there, I think both of these divide by 2. 2 goes into 2, and 2 goes into 4. So if we say 2 goes into 2 once, 2 goes into that once, 2 goes in here twice, another way we could write this answer out with imaginary answers would be 2 plus or minus I square root of 12. Those would be the imaginary answers. They're not real solutions, but they would be imaginary solutions. All right. For your worksheet, then try some of these out. See if you can work on these factoring ones, and then see if you can solve for the solutions.